Hello everyone, and this is Devabrata here, and welcome you to all of you of our channel Schrodinger's Cat. So basically, we had discussed in our previous lecture that the magnetism from class 12, and today we will discuss work, energy and power from class 11. So we had now covered here the topics work, kinetic and potential energy, work energy theorem, conservation of energy, and the power, motion in vertical circle, collision. And total questions are coming in the entrance exam like NEET. There are 2 or 3 questions, in JEE main 3 or 4, and the JEE advanced 3 questions are coming in this exam. So let's get started. First of all, we just discuss the work, energy, power, and basically I just draw a line for your better clearing. I just say one thing, that for your exam point of view, we just now discuss here the chapter summary in a nutshell and do problem from the NEET, JEE and advanced previous year type questions and give homework, and after we just got time we just discuss the theory elaborately. So first of all, in the work, energy, power, that suppose this is d distance and the force acting in this direction F and the angle theta, and this is the component of F cos theta. So the work is W equal to F dot D, is written as the FD cos theta. And there are 3 motion: circular, planetary and motion of electron around nucleus. So rate of work done is defined as the power, P is defined as the dW dt is F dot V, force into velocity, and the kinetic energy Ke is equal to half mv square, and the gravitational potential energy, Gpe is equal to mgh, and another one the minus mg z mm by r, e to discuss in our gravitation chapter. Next one, relation between kinetic energy and momentum. So kinetic energy Ek is equal to p square by 2m, and so p equal to root 2 me. Potential energy stored in a spring compressed through distance x is written as potential energy Ep is equal to half kx square for the string, and the work energy theorem W is equal to difference of the kinetic energy K final minus kinetic energy initial is written as the half m V final square minus V initial square. This is the work energy theorem. Suppose spring constant when a spring is cut into ratio m:2n. This is important for JEE type aspirants. So this is a spring here. We just cut in this side. This is length L. So this cutting ratio is m:2m. After coupling, this one is 1 and that one is another. So after cutting, K1 spring constant would be m plus n divided by, this is very important, K, and the L1 would be m by m plus n into L total. This one is L1 and this one is the L2. Second one, the K2, another spring constant, m plus n divided by n into K, and the length n by m plus n into L, total length. So Suppose the force is in the component that the fx along x-axis and the fy along z-axis, y-axis, then condition for this force to be conservative force that written as del fx del y, that this is basically del of y, just written del suffix y, written as keeping derivative of fx keeping x constant, and this is the del of fy, derivative of force component of y keeping x constant, that is del x. So for basically conservative force you just go through in your BSc course that curl F equal to 0. So this is written in this form. So next one, discuss that the center of mass, momentum and the collision. Just draw a line. So here the center of mass of two particle system, that this one the M1 and the M2, and this is the origin x and the y. So here this one is x1 and this distance is x2, and this is the center of mass point. So this is the xcm. So center of mass, that the xcm is equal to m1 x1 plus m2 x2 divided by m1 plus m2. Center of mass of a system of n particle. So for system of particles, suppose this is m1 and m2 dot dot, here this is mn, this is the r1 dot dot dot, here this one is rn, and this is the center of mass c is rcm. So center of mass, that the rcm is equal to m1 r1 vector plus dot dot plus mn rn vector is divided by m1 plus dot dot mn, written in the form that 1 by m total mass sum over I 1 to n mi ri. So this is the for system of 1 by means m means basically the I 1 to n mi, mass of ith particle. Expression for center of mass for the x coordinate xcm is written as 1 by m summation mi xi, for y ycm 1 by m summation mi yi, for z coordinate zcm is equal to 1 by m summation mi zi. This is the xi, yi, zi and the coefficient of the ith particle. So expression for center of mass of a rigid body, this is also important for your JEE aspirants, that the center of mass xcm is written as the x dm divided by integration of dm, basically this is written as 1 by m integration x dm for continuous system of particle, where the integration of dm is equal to m mass of center of mass. For ycm also written as the 1 by m y dy, sorry, basically the y dm, this is written as the x dm, this would be the dm, and the z coordinate of center of mass 1 by m z dm. where integration dm is m, written as the mass of the rigid body. Mass of rigid body. Velocity of center of mass. So velocity of center of mass, that VCM vector, that 1 by m simple m1 v1 plus dot 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 m n nth component of velocity, and the acceleration ACM written as the 1 by m m1 a1 plus dot 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 plus mn an. So basically here the Newton law written in this form ma, that MACM is equal to F external, where F external is the vector sum of all the forces acting on the particle. This is for the Newton law of system of particle. System of particles. So impulse is written as the change of momentum, that del P is equal to P2 minus P1 is the Fx dt, F dt. Principle of conservation of linear momentum, that if the F external would 0, that imply that the dp dt is equal to 0, so p would be the constant. Time derivative of a vector is 0 means this vector is constant and remains unchanged. The condition here, that F external is 0. This is the condition. Next one. So elastic collision in one dimension. Suppose this is a block here, mass m1 and m2, v1 velocity, v2 velocity, and after collision that the velocity would become v1 dash and the v2 dash. So kinetic energy will also conserve here, that linear momentum conservation m1 v1 plus m2 v2 is equal to m1 after collision m2 v2 dash. This is one linear momentum, and the kinetic energy will also conserve for the elastic collision, half mv square. So half m1 v1 square half m2 v2 square plus half m1 v1 dash square half m2 v2 dash square. This is equation number 2. So solving this equation 1 and 2, we just get the velocity after collision, that v1 dash is equal to m1 minus m2 by total mass m1 plus m2 into v1 plus 2m2 by m1 plus m2 into v2. Another one, that the v2 dash equal to 2m1 v1 by m1 plus m2 minus m1 minus m2 v2 by m1 plus m2. This is basically the velocity after collision. So now go at our special case, that elastic collision between a heavy body and a light body. Special case, suppose the m1 mass is greater m2. So in that case, that v1 dash nearly equal to v1 and the v2 dash would be 2v1 minus v2. Suppose m2 is greater m1. So in that case, that v1 dash would become minus v1 plus 2v2 and v2 would become v2 dash would become v2. Elastic collision of two bodies of equal mass, this is very important. m1 and m2 when is equal, then v1 dash would be v2, v2 dash would be v1. So here the beauty is that when two bodies of equal mass collide elastically, their velocities are mutually interchanged, v1 to v2, v2 to v1. This is very important. Next one, perfectly inelastic collision in one dimension. So for inelastic collision, that we have get the common velocity. This is for the inelastic collision, that the v common velocity. So in that case, linear momentum m1 v1 plus m2 v2 is equal to m1 v plus m2 v. And second one, the half m1 v1 square half m2 v2 square is equal to half m1 plus m2 common v square. So you just get the common velocity m1 v1 plus m2 v2 divided by total mass m1 plus m2. And another thing is as coefficient of restitution. The coefficient of restitution written as the E is the relative velocity of separation just after collision. So after collision v1 minus v2 and relative velocity of approach before collision, that the before collision relative velocity v1 dash minus v2 dash, and the range is 0 less than e less than 1. This is basically coefficient of restitution. So we just cover here our theory discussion sessions. Now go ahead our problem discussions. So first of one is NEET new type questions, that force F on a particle moving in a straight line varies with the distance d as shown in the figure. You have to find the work done. So for solving this is 2011, we have know the work done is area of force and displacement graph, FD graph. This is the work done. So here in this type of figure the work done would be that this, for this case 2 into 7 minus 3 base into height, plus for this triangle half into base into height. So height would be 12 minus 7. So this is the 8 plus half into 10. So 13 joule would be your answer, C. Next one is NEET 2019, saying that a object flying in a air with velocity this in a vector form suddenly break into two pieces, ratio m5m 1:5. Smaller mass velocity is given in these vectors. You have to find the velocity of larger piece. Conceptual question, very important for your NEET exam. So that m mass with velocity v is broken into two parts. This is the mass of m by 6 velocity v1 and this is the mass of 5m by 6 velocity v2. So summation mi vi is equal to summation of mf vf, linear momentum conservation. So 1:5. So we just first one mass velocity. So after breaking m by 6 v1 plus 5m by 6 v2, linear momentum conservation, you would solve this, get v1 by 6 plus 5 v2 by 6. So given v is this is the given v and this is the v1 given, v and v1, you have to find the v2. So for finding v2, you just put this value in these equations, that v means 20i plus 25j minus 12k is equal to v1 by 6, that multiply by v1 by 6, that v1 is given 100i plus 35j plus 88k divide by 6 plus 5 by 6 v2. So you have to get the v2, that 1 by 5 times of 20i plus 115j minus 80k. So it would become that 4i plus 23j minus 16k. So I think A would be our correct answer. 4, 23 minus 16. A would be our correct answers. Go ahead, our next problem. JEE NEET 2019, recent type of questions, very important. A block of mass m is kept on a platform which starts from the rest with constant acceleration g by 2 upward as shown in the figure. Acceleration g by 2. You have to find the work done. So we just here consider equation of motion. For this equation of motion, that this block, so mg here and here the n. So n upward, mg downward is equal to ma. Here a means g by 2. This is the simple equation of motion. You have to find the value of m, n, so g plus g by 2. So 3mg by 2. So you have to find the s equal to ut plus half at square. Here u is equal to 0 in rest. Just put this value half. A means g by 2 into t square. You just get gt square by 4. So now w equal to fd, force into distance. So 3mg by 2 into is the force and the distance is gt square by 4, that 3m g square t square by 8. So B would be our correct answer, 3m g square t square by 8. Go ahead. JEE Advanced 2013. The work done of a particle of mass m given in this form. When the particle is taken the point a0 to point 0a, you have to find the work done. along a circular path radius a, and you have given the force here. You have to find the work done. So this is a circular path, origin x and the y. This is radius p point. Here this is x and the y. Here r is xi plus yj, and the force is given that k by x square plus y square to the power 3 by 2 xi plus yj, that is equal to k by, this is means the r square is equal to x square plus y square, so k by r cube, this is the r vector, k by r cube into r vector. This is saying that force is along the r, this is the r, and the force direction is this is force, and here r cap. So here force is along the direction of r, so f dot r cap is equal to 0. This is equal to work done, so work done would be 0. D would be our correct answer. So this is a JEE advanced question, but logical and conceptual. You just keep in mind this type of questions. Next, JEE MEN 2022. As per the given figure, two blocks each of mass 250 grams are connected to a spring constant K each 2 Newton per meter. If both are given velocity v in the opposite direction, the maximum elongation of the spring is. Maximum elongation, that means the x max you have to find. So this is a spring of this type of velocity v, and this is the v. So elongation means this spring is stretched in the direction. Suppose this is a center of mass, and this and this spring is elongate. Suppose this elongation is x by 2. So you have to find that m 250 gram means 0.25 kg. So we just here the energy conservation, and one thing I just say to you that the energy conservation is very important solving the problems of JEE, like momentum conservation, linear and angular momentum, energy conservation, potential energy, and the kinetic energy plus total energy after is equal to kinetic energy and total energy before. So this is the origin and this type of v. So half mv square into 2 side is equal to kinetic energy, suppose potential energy of the spring half kx square. So put this value 1 by 4 v square equal to half k is given 2 into x square. You just get the elongation x is equal to x square 1 by 4 v square, that is equal to x equal to v by 2. So B would be our correct answer, v by 2. So we just cover here 5 important questions coming in JEE MEN NEET and exam. So I think after doing this 5, you just try to solve the all another exam questions coming in JEE MEN NEET and JEE Advanced. So for your better practice, understanding and conceptual, I just usually give you 5 another problem for your practice. You just pause this video and take a screenshot immediately. So I just wait 5 or 10 seconds. So I think you just pause this video and take a screenshot. So I just cover here the 10 important questions from the work energy from class 11. So last but not the least is the contact. Solve this homework, and if anyone needs or file of my YouTube lecture, just mail without no hesitation our favorite mail ID catschrodingers1935@gmail.com. So last but not the least, that thank you everyone, and stay happy and well, have a good